Welcome to another GCBASIC demonstration. Please like this video and subscribe. Those statistics help fund this project. So this is a primer of how to install and getting started. GCBASIC is a compiler and toolchain. It allows you to support and develop programs for microchips PIC, microchip AVRs, and logic green technologies, AVRs as well. So it's an 8-bit compiler and it's a complete toolchain, and we're going to see various parts of that during this video. What we're going to do is install the software. We're going to install some programming software. You will require that if you're using a PIC, and test you have a microcontroller attached. So to download the software, go to sourceforge.net, projects, GCBASIC, and install using the default values. And we'll do that very quickly. Let me show you how I would go about doing that. I would go out to Google. Let me just show you how I would do it. I go to Google, I would type in GCBASIC. I would then go to, and I'll zoom in on that for you so you can see it. I would go GCBASIC Home. Then I would take the download option at the top. And there's a simply click here to download the software. And that will download you the latest version. I've already done that. And so it's sitting here, and I can click on GC Studio XE, click, and it will start the installation process. You will get a warning. Do you want to allow this app from an unknown publisher to make changes to your device? Say yes. You may also get another alert from Windows, and we will be resolving that during 2024 by installing a certificate in our applications. So welcome to GC Studio Setup. Take the defaults, press Next. Read the license agreement. It's an open source license agreement. It's a GPL license. Read it. Agree. Install it to the default folder. And I'm just going to say run when finished. That one means it will start the IDE, and then do not select legacy mode. Whilst it's installing, I'll just cover those two off, shall I? So it's going to open up the GC Code Integrated Development Editor, or Environment IDE. The legacy mode would open up an older editor. We're not developing the legacy mode anymore, so take the new one. And that's the one that will be shown today. There's a lot more features. It's a lot easier to use and learn. What it's also going to do in a moment is pop up a message about installing some software. I have a license for this software called PIC-Kit Plus, and it enables me to rapidly program microchip PICs via the PIC-Kit Plus software. So I'm going to clone my installation. And so if you need a license, go to pickKitPlus.co.uk and you'll see the details there. And so it's just completing the installation. Why don't we have a look what's on the desktop? So what I've got, look, is a PIC-Kit 2. I'm going to hook that up with the programming interface to my board. And this board is my board. Your board could look like this. It could be a prototype board like this. Doesn't really matter. They all do the same thing. Well, I've got a microcontroller sitting here, and I've just connected it through here. I've got some voltage down here because this red LED is on. And what we're going to do is to flash that LED in a moment. Back to our installation. Well, our installation has nearly finished. Clone your existing PIC-Kit Plus installation to GC Studio. I'm going to select that and press Finish. It opens up GC Studio in the background, but I want to clone my installation. So I'm going to press OK. And I'm just going to take my old installation in GC. I have an older folder, and I'm just going to select the folder where PIC-Kit Plus was installed and select that folder, and it will just install the software for me, which it's already done. There we go. Replace it. And now it's successfully cloned my PitKit Plus installation. So what we've got in front of us is the new IDE. Let's zoom out and see the whole thing. We've got icons at the top right-hand corner, and they'll become self-apparent shortly. Then we zoom in, press Control Plus, and it will make everything larger. And these icons up here help you. They make you can flash, create an assembly file, create a hex file, and program it. But you can also do the same via the function key F4, which we'll look at in a moment. Essentially, anything in green is comments, and we have a small program down here that says, I'm going to use a particular chip called a 16F886. Pick your own poison. We're going to change that shortly. I've got a little loop called a do forever loop, and inside of there, I'm going to pulse the port B.5 for 100 milliseconds on, and then turn it off. And that's all our program's going to do. So how I'm going to make this work? I'm going to press function key F4 and type in hex, and it will make a hexadecimal file. If I press enter or the shortcut you choose, it will compile it up. It will beep at the end to say it's completed it, and it will ask you to donate to the project. But it says it's done. If it hadn't done it, it would have come up with an error. I'll put an error in for us. Random code, function key F4, select make hex, and it will create a syntax error. And it will show us where the syntax error is in the program. I can click on syntax error, and it clearly takes me to the line where I have my error. So we can create a hex file, and it's done it in a few seconds. How do I program it? Press function key F4 and type in the word prefs. You can type in edit preferences or pref for short. And it opens up a little window that looks like this. Essentially, there's a list of programmers. Most of the programmers are installed for you, so you can select them and it will operate, except for PitKit Plus, which I just cloned. So it should work. The list of programmers to use in order is an Uno, and we'll come on to that shortly, PitKit Plus, LGT, and other boards. Well, essentially, there's a set of rules, and it will automatically select the PitKit Plus for us. So if I press OK, it won't change anything, but what it will do, it will enable me to just prove to you that it's actually going to flash. So function key F4 in the IDE, if I type in the word flash, make hex and flash. There is a shortcut to that. Let's have a look what's happening on the desk cam. In the desk cam, something's happening. In the IDE, there's a lot of commentary coming up. It's actually erasing the chip, and it's now just completed its process. It's now flashing that LED. So it has programmed it. We can see that back in the IDE. It says here, it's done. It's done it completely. Now I can get rid of some of these this long messages in here. I can press function key F4, type in pref again, open the preferences editor, and I can change a setting in here to make it less verbose. Suppress summary mode is always good. Mute the banners. Press OK. I can actually quieten down the programmers as well. I won't do that today. So let me just press OK, and I'm just going to change the timing just on this demonstration here, just so to show you that there's less dialogue in here now. It's compiling it, it's assembled it, it's now downloading it. And if we look at the desk cam, it will take it in here, it will now flash it rapidly because I changed it to rapid. How do I change it to one of these? This is an Uno. Is it an Uno? It looks like an Uno to me. Let me zoom in on that. There's an Uno. Trying to get that out of the way. There we go. There's an Uno. Nothing happening on that. So in my source program, I'm going to change my chip here to a Mega 328P, and I'm going to program it. Let me just check the programmer's interface. Internet Presso editor again. Function key F4, pref, edit the preferences, zoom in it for you. Arduino Uno at a particular baud rate. Edit. This COM port here needs to be correct. COM port 0 is the default, and as there is no COM port 0, you have to select the one that it's attached to. And the Uno presents itself as a COM port. I select that COM port, press OK, OK, and I'm back in the IDE. Once I'm back in that IDE, I can press Function key F4, select Make Hex and Flash, and it will then compile, it will assemble it, and then download it. And out here on the desk cam, I have a flashing LED, which wasn't flashing before. Something's happened because GCBASIC has successfully compiled, assembled, and provisioned a hex file specific for this chip, and then it's programmed it through the available programming interfaces. So what have we seen? We can see that this is a complete IDE. We've got our programming interface at the top. We have messaging at the bottom, which we can close by pressing the X key. We have icons at the top that do much of the same. If I want to program it, I press this one here called H with an F over it, and it's essentially the same as pressing Function key F4 and selecting Make Hex and Flash, and it's now doing it. It's already programmed it in those few seconds. Once the project's funded every year, these messages disappear, so it's even faster. It's just we need funding on the program. So what I wanted to show you was a quick primer. We installed the hardware, we made the board work, and we flashed a LED. We had a prototype board. One was powered to 5 volts, the other powered to 3.3. I don't really care. But our LED was consistently attached to port B.5, hence the program works in both cases. We had a programmer. That programmer needed software. I used a PitKit 2 with PitKit Plus software from www.pitkitplus.co.uk. And of course, both of these boards had LEDs and resistors. But essentially, same program, different interface in terms of programming. So what I wanted to show you was a quick installation guide and getting started. Essentially though, remember, Function key F4, that's where the magic happens. We'll call that a wrap.